My name is Nakiran. You can call me Nax. Welcome to this lecture on Ohm's Law. In this lecture, we look into Ohm's Law that connects the voltage and current in an electric circuit through the resistance value of resistor. Consider the electric circuit shown in the figure with a battery supply voltage of V, switch in open position, and a resistor of resistance value R. As switch is open, no current flows through the circuit. When the switch is closed, current flows through the resistor as the battery potential V is applied across it. Ohm's law states that the current I flowing in the circuit is directly proportional to the applied voltage V. This means when the voltage is increased, current will increase. When the voltage is decreased, current will decrease. Proportionality between the current and voltage can be made as an equation by the introduction of a constant parameter. From the circuit, we can understand that the constant parameter has to be related to the circuit resistance R. Let us derive the constant parameter using the units of the quantities involved in this equation. In any equation, right hand side and the left hand side must be balancing all that are connected to the quantities. Units must also be balanced on both sides of the equation. Left hand side is current I with ampere as the units, so the right hand side must also be in units of ampere. Thus, voltage R units volt multiplied with the units of the constant parameter must be ampere. Hence, units of the constant parameter must be ampere divided by volt. Reciprocal of R units will be ampere divided by volt. Thus, we derived the constant parameter to be 1 over R. Ohm is the R units, which is a derived units of volt divided by ampere. Units of resistance is named as ohm to honor the scientist who provided us the Ohm's law. Thus, we derived the mathematical model equations for this electrical circuit as I equals V over R for current, V equals IR for voltage, R equals V over I for resistance from the Ohm's law. Let us solve a circuit problem using the model equation derived using Ohm's law. Calculate the current in microampere consumed by a computer wireless mouse with a resistance of 10 kilo ohm powered by a AA sized battery. It is a good practice to draw an equivalent circuit and mention the provided data appropriately. From the circuit, we can write the model equation derived using Ohm's law for solving the problem. It is a good practice to write down the model equation or the formula with the units that can help collecting the data in appropriate units. Write down the provided data that are essential for solving the problem using the model equation. If required, convert those data into the units necessary to substitute in the formula. For the first step in calculating the current in microamperes, first calculate the current in amperes. It is a good practice to use the units and simplify them as well to check whether they correctly reduce to the units of the left hand side subject quantity we are calculating. Note that in the right hand side units volt divided by ohm simplifies to ampere, which is the units for the current we are calculating in this step. Finally, calculate the current in microamperes by multiplying 1 million to the current value we calculated in amperes. Factor 1 million is multiplied because 1 million microampere is equivalent to 1 ampere. It is a good practice to double check every step of our calculation and the final answer as well for the correctness. Thank you for listening to this lecture. Goodbye until we meet in another lecture.